Okay, hey everyone. So today I have a second year student from the University of Waterloo. And yeah, would you be able to just give a quick background on yourself?
Yeah, for sure. So I'm a second year CS student at the University of Waterloo. I'm interning at a small fintech company based in downtown Toronto.
Right.
It basically like sells loans. I'm working on a bit of full stack with like Spring Boot and Angular, and just like at implementing new features on the same. I've done about like 184 lead code questions till date. I still wouldn't say I'm really confident, but I'm getting there. Yeah,
hmm
that's all from my end.
Okay, when did you start coding?
Me, I think it was like ninth grade. I just learned a bit about basics of like Python.
Nice.
Like learned a bit more about like object oriented programming, and
hmm
then yeah, like from there like a bit of full stack, and then yeah, like university, I learned about Racket and C, and then second year it's going to be C++ and like data structures. So I haven't taken a data structures course yet.
Yeah, yeah, I see. So what was your question? You're asking me what happens when you become a manager?
Yeah. How does the role like vary from like let's say a staff, and then what does the progression look like? Can you become like let's say a VP or director like without being in management?
It's different. It's a different skill set to succeed in the different roles. So there's the individual contributor route. What does it mean as an individual contributor? You're pretty much just writing code, and you're an individual contributor. You're doing stuff like individually. I mean, you work in in the context of your team, but you have like the output that your output is coming from you versus when you're in a management role, you're not a lot of times you might not actually be directly contributing, but you're working with a team and you're telling that team what to do, and then they're implementing the code, and sort of your work is their work. What they're able to produce is a reflection of how you manage them, kind of thing, and that's more of how you're assessed. Like, how can you tell someone's a good manager? I mean, one way people would say is how well is their team performing? How good are the features that their team are performing? That's obviously, you could just have a really good team and just suck as a manager, but that's the main way that managers are being assessed a lot, is how well are they managing the team, and then how do you track a team's performance? Well, what's the output of the team? How, like, if a team is handling a service, how often is that service down? How often are they pushing new features and advancing the code? Does that make sense?
Yeah, thank you so much. That answers my question.
Yeah, and there's different levels of being a manager. You could start off at the bottom level of a manager, where you're just managing a bunch of software engineers, right?
Right.
That's usually level one. What's level two? Level two, you're usually managing other managers. So maybe you have a team of managers and you're managing those managers, and they're managing the actual software engineers. And then
Got
there
it.
might be a level above that. Maybe you're the director of AI. So maybe you have like you're a manager of managers of managers, kind of thing. You're leading a whole organization, and there could be multiple levels under you.
Got it. Thank
Yeah.
you so much.
And when it comes to software engineering levels, like junior, intermediate, senior, it's I think the main thing is more. So when you're from going to junior to intermediate, it's pretty much all about execution. So to see if somebody's still a junior is you give them some task, and it's well scoped task, and they still can't finish it in a reasonable amount of time. Usually you want them to be able to finish tasks in a reasonable amount of time before they become intermediate, and you also want them to do it with not as much guidance. If you have to guide them really hard on every single feature, they're still a junior engineer,
Got it.
right? So I think it's more about just execution and autonomy. When you get to intermediate, it's more about you still it's still about execution. You still need to execute, but the problems you're solving are becoming more vague. And of course, like, you need to be autonomous, but vague as in there are multiple solutions to solve the problem, and you need to talk with different people to understand how to solve that problem and choose the right one. So it's not just coding anymore, but it's figuring out, like, it's requirements gathering. It's involves some people skills in it. Does that make sense?
Yeah.
Yeah. And then, yeah, in intermediate, you'll start doing stuff like getting on call. You might be asked to do things like or you start thinking about the systems as well. But I think when you get to senior, that's when you have I would say you would have full scope of the system. You're handling everything from on call, right? Taking all the on call issues, not just on call, making sure on call is not noisy. Building out the testing system so that your system is, like, you can track when issues happen. Architecting the system so that your system is a good system. You know what I mean?
Yeah.
Like, if you realize that latencies are very high, people pretend you're building a newsfeed and the newsfeed is really slow. You can go in there and make that newsfeed faster. So you're working at a different scope than maybe an intermediate or a junior developer.
Got it.
Yeah. Any other questions, or that's it?
No, no, no. We can get into the
All
technical.
right. Sick. So how are you familiar with the? How familiar are you with the other, with like the different, like, arrays, backtracking, etc.?
Uh, so not so much with backtracking. I've done like I would say I know quite a bit of trees, linked list, and then I was recently doing DP. I've forgotten a bit of graphs because it's been a while since I've done like all the like topological sort and like all the like Kahn's algorithm and stuff.
Mm-hmm.
But yeah, apart from that, I think and backtracking, like I've done heaps as well. So like apart from like a bit of graphs and like backtracking, I think I should be somewhat. I should have an idea how to solve the problem, like somewhat. At least I hope so.
Okay, sounds good. Okay, so what we have here is an interactive code editor. We're gonna prioritize working code. What language do you want to work with?
Python.
Okay, sounds good. So I'm gonna post in the very first question. We're gonna be and tell me if you've done this question before. I can switch it.
I have done this before,
Okay,
but
okay.
yeah.
Let's change it up. Let's change it up. I'll find you a good question. Okay, I'm gonna post in the first question. Hopefully you haven't done this one.
No, I don't think I've done this.
So there are n people standing in a queue, and they're numbered 0 to n minus 1 in left to right order. You're given an array of heights of distinct integers, telling you the height of each person. A person can see over another person to their right in the queue if everybody in between is shorter than both of them. So return an answer array of length n where answer I is the number of people the I person can see to the right in the queue. So I'll show you this. So we're given heights as a list, and this is our output. So we just need to return an answer of the number of people the I person can see. So these are heights. So this person is height 10, this person's height 6, this person's height 8, this person's height 5, 11, 9, etc., right? So person 10 could see 3 people. They can see 6, 8, and 11. I think. Wait.
6, 8, and 11.
Let's see. Oh. We have the list. Or this is the. Yeah. So person could. It's going by index. So it's like 0, 1. Are you downtown Toronto?
Yeah, yeah. Can you hear it? Should I mute
Sorry.
myself?
No, it's good. It's good. It's good. I live in downtown SF, so you just hear that all the time too.
Yeah.
Is it right outside your house though?
Actually, I'm just next to U of T's campus. Like, there's like one ambulance going in every hour.
I
So,
see. So person 0 can see 1, 2, and 4. Can you tell me why?
person one can see one, two, and four.
Person 0 can see
Uh,
1, 2, and 4.
sorry. Yeah, person zero. like it has to be shorter than 10, but like wait, it has to be the ith person can see the jth person if I is less than j. That means basically the index, obviously it has to be towards the right, and the minimum of heights of I in j is greater than the maximum of heights of I plus 1 heights of I plus 2. I'm still trying to process this. Like
Sure.
minimum of heights of I, let's just assume that j is like 6, sorry, index 1, and then I is basically 0. So minimum of 10 and 6 gives me 6, and that should be greater than max of heights of I plus 1, which is going to be max of 6, 8, etc.
Honestly, this is weird to look at. Let's just look at this right here. So 10, what does that mean? 10 has a height of 10. And if it
Yeah.
looks to the right, it could see 6, it could see 8. Why can't it see 5?
uh I'm not sure, like
Well, because 8 is taller than 5. So let's look at it in come to the drawing.
yeah, just a sec.
So we can look at it like this. 10. This is 10. We have 6. 8, 5, 11, 9. So let's just do 10. So these are the numbers, or these are their heights. This one's height 10. This one's height 6. This one's height 8. This one's height 5. This one's height 11. This one's height 9. So we're saying can see person 0 can see 1, 2, and 4. Like person 0. These are the people 0, 1, 2, 3, 4, 5. Because this guy is smaller than him, he's kind of hiding.
Oh, okay. Okay. The guy is hiding, right?
Yeah, you see, like this guy's taller, so you can't see him.
Right.
Yeah.
And
Okay.
and person
Who can
two can
person
similar
one see? Who can person one see? This is zero
only
index.
only two,
Yeah, person one can only see two. So this is
and
three. So they can only see one person. What about this guy? How
two
many
can see
people?
3 and 4.
Yeah. So two. What about five?
Can I say that the one at index 3 or 5 basically can see both at index like 2 and 4, but like it can only see like towards the right, right? It can't see towards the
Yeah, I could
left.
only
If
look it to the right.
yeah, so then that's just 4.
So it's just they could just see one. What
Yeah,
about
just one.
person four? How much people can person four see?
Yeah, just one.
Okay, how about person five?
0.
Yeah. So you see how we get that output there?
Yeah.
Okay, I'll let you go now.
Okay.
I'll
Yeah.
let you jump up there.
So like the first thing that comes to my mind is like this is like a problem of utilizing like a monotonic stack. Like I'm not sure if it's going to be in increasing or decreasing order. So like I'll have to keep appending to the stack and keep popping based on few conditions. Like if probably like that is something that I'll have to figure out. Like if like the height at index at the I plus 1 at index, if it's like less than the last element in my stack, and like so on. So like let me just begin this problem. I'll just like define a stack to be like let's just say I have a stack which is empty, and then let's just like should I just I'll just create a function def
Let's talk about your approach first before you hop into
oh,
coding.
okay, sure. So what I'm thinking is somewhere I know for a fact I'll have to use a monotonic stack. So like what I'm thinking is how many times will I have to pop, and what the condition for that would what the condition for that will be. So
So why are you saying we need to use a monotonic stack as well? Could you
because we're like
elaborate?
maintaining a particular order, like it could be either decreasing or increasing. um and then like like append and like pop from the queue accordingly, so that we can effectively decide like how many people that we can see compared to like a normal stack.
Okay. So let's just do this. Take this array. Like, how would we build up that monotonic stack? I'm not sure I understand your approach.
um so like maybe I begin by like what if I'm just thinking like what if I start from the end of the array, like I traverse it in like the reverse direction. I'm at 9. Let's just say I start at 11, right? I basically add like 9 to my stack. So my stack currently contains 9.
Sure.
And then I check 11. 11 is basically this starts from like length of like array minus 2. And then I check if that number is basically greater than the last element present in my stack. So we know for a fact that 11 is greater than 9. In that case, I I'm thinking like should I have a no? I don't think there's any need of a counter variable. I probably pop that from my stack. So if 11 is greater than 9, then I pop that from my stack. Um, and then but what do I do with the popped element? Like the effectively uh, what I'm trying to figure. Okay, yeah, another thing, like another edge case that like I can think of instantly. We know for a fact that the last element is always bound to have like can see no one else, because he's basically the guy standing at the front of the queue.
Mm-hmm.
So he can only look forward and there's no one, so it's going to be initialized to be 0. So we
Sure.
know for a fact that a resultant array, the last element is going to be 0. And
Okay.
then what I could do is or like what if I instead start like from the front of the array, like I'm probably I was thinking of using like a reverse approach where I'm iterating the array like in reverse order. What if I begin from the front and then see, maybe that makes a difference. I'm not sure which method would lead me to the correct answer, but then we can reason through both.
Sure.
So like uh, I'll like inside my resultant array, I'll just initialize that to be like none, and like times the length of the array. And then in the last element, I'll just put 0 there. And
Mm-hmm.
coming to the logic, what I'm thinking is
So what are could you just show that like zero, like we're gonna be like a
sure,
bunch of
sure, sure,
nuns
sure,
in the
sure.
result.
So yeah, so like let's just say this is the resultant array. It's going to be initialized by none times the length of the array, right? And then basically I'm going to say res of -1 is basically equal to 0,
Sure.
because that's basically going to be the last element in my resultant array.
Yep.
And let's just say this is the array as of now, so that I'm not getting an error. Um, wait, why this is highlighted?
Okay. And then you say we're gonna try going through the front of the array, the back of array.
Yeah, that's what I'm trying to figure out. That like if I think like since I've already initialized the last element to be 0, I think it makes more sense to start from the end. So like let's say I start from like for I in range len of array -2. This goes until the 0th index, and then I'm decrementing by 1. uh, yeah, and then basically I check that if my current element, which is array of I, if that is or it should rather be while, because then I could have multiple elements. While array of I is greater than the last element present in my stack, I keep popping from my stack. And otherwise, like I'm just thinking about the logic that like for example, like we know that 10 can see 6, 8 and 11, right? So like do I maintain like does that depend on the length of the stack, that if I have 3 elements in my stack, in that case the resultant answer would be 3. So that's something that I'm trying to reason through.
Mm-hmm.
So okay, so like let's just think about it. I'm currently standing at 11, and I know that um like okay, I should probably initialize my stack by the last element in my last element in my array, right? So like ideally speaking, stack of -1 should basically be nine array of -1, or like we could just say stack of zero actually, since there's like no element. Yeah, and so I already have 9 in my stack at this point. So stack is equal to 9, and I basically see that my first condition is that 11 is greater than 9. So in that case, I pop 9 from my stack, and I guess I move forward. Um, so like now I'm at 11, and like there's basically no element in my stack. So I guess I'll have to, inside my while condition, I'll have to check while I have an element in my stack, and like array at index I is greater than the last element present in my stack, because that's really important that my stack is not empty. Then only can I pop from my stack. But I'm still trying to reason through my logic as to when I'll see three, one, or two, like what would my approach be for the same? Like something I'm thinking is, I'm not sure, but is it something to do with like the length of the stack, like the elements present in my stack? Does that give me three, one, or two, one, etc.? So
The length of the stack.
yeah, I don't think that's how I would do it though. I'm just thinking about it.
What I would do is, can we try simulating your approach in the comments to just see that it yields the right result?
Sure, sure, sure. So stack basically contains 9.
Sure.
uh this is basically so this is like 1 2 3 4 5 6. So none, 3 4 5, and then last element is initialized to be 0. And then basically I'm iterating through my array. I'm at 11, and I see that there's one element in my stack, and I see that 11 is basically greater than the last element present in my stack, which is 9. So in that case, I pop it, um, and but like I think, but like if I know that 11 is greater than 9, so that means that I found one element. So basically that gives me the one here, which was shown in the xcali draw, where basically like we're basically iterating through it in the reverse order. So I should set it to be 1. But then I'm just thinking, like, should I use like a separate counter variable which counts it? But then how do I keep track of that for like every single height? That is something that I'm considering right now, because I'm not sure what exactly would I be doing there. So yeah, so like if I've popped it from the stack, I guess I could do uh, res at what index would that be? Res at index I, right? Res at index I would be count, I guess. But then like there's no point of maintaining a separate counter. I don't think using a counter would help here. um, bec- because like I'll have to keep track of the state for every single height. So I'm just thinking, what other method could I use? Like, is the length of the stack something useful in this case? But then again, like if I'm popping from the stack here, I have no element present in my stack. So how would I get one? That is something to consider. And or what if, like, instead of popping, if I appended that to my stack? In that case, I'll have 9, I'll have 11. Um, I'm still thinking about this. Like, what would my approach be? So the ith person can see the jth person if I is less than j, and I guess I can skip that. I should like look at my monotonic stack approach only. But um,
Okay,
so
you
while
popped out the. So how do you fill in? How do you know using the monotonic stack? Because you introduced this monotonic stack, but how are we gonna use the monotonic stack in order to achieve our goal? I guess because you just mentioned, yeah, we need to have a monotonic stack. It's gonna store things in either decreasing or increasing. But how is the knowledge of what's increasing or decreasing before us going to help us figure out our result?
I'm forgetting like how we used a monotonic stack, but then like for some reason I'm thinking of using the length of the stack, but I'm sure like that's not the case. So I'm just thinking
What would
about
the
it.
length of the stack give you?
Like the length of the stack will give me basically like for basically the resultant array. So like for example, if there are three elements in my stack and I've reached like index zero, so in that case I'll just do like res dot append the length of the stack, and then I presume at that case there's going to be three elements in my stack.
Wait, could you repeat that?
Uh, like I was thinking that basically, like if I'm at index zero and then assuming I have like three elements in my stack, so in that case the length of stack is three. So in that case, I just do at the ith index, I basically append the length of the stack, which will give me three. But I think that is wrong, to be honest.
So let me see if I give you a hint here, advice. I mean, let I think we need to. You are going the right approach, but you're going in circles because you're not simulating it properly, right? Or simulate it all the way through, and then work from there. As in simulate it and then actually update the result and then move this pointer back. Tell me how the stack works. Like simulate the whole thing. So we start with nine. Nine is zero. Yeah, we know that. We move to 11. What happens now?
The like I compare that with the last element in my
Okay,
stack,
and then what?
and like I'll have to decide that if I'm maintaining a particular order, will I pop it, or would I just let it be remain in my stack
Okay,
and move forward with the next set of iterations?
okay. So what are the options? You can either, if you pop it, what happens? It becomes a
If I
monotonically decreasing stack or an increasing stack if you leave it, because that affects it. Like the condition you're building here affects it.
so like if I leave 11, right? So then I have 9, then 11. So effectively, I have a monotonically decreasing stack, right? Because like a stack is last in first out.
If you leave 11 or if you put 11,
Like I'm just thinking, which direction am I seeing it? Is it like 9 to 11 or is it 11 to 9? Because that depends if it's like increasing or decreasing, right?
well, like if it goes 9, 11, 12, that's an increasing stack, right?
Right. So in that case, like I'm probably following a monotonic increasing approach where basically if I'm letting it stay, then it's increasing. But then what I was discussing so far was like a decreasing approach that I'm if it's a greater element, I just pop it. But then like if I'm at 11 and I see 5, so that means in that case I'll have to let it remain in the stack, right? Because
Okay,
it is
let's explore. Let's explore both. Okay, let's say keep it. That means it's an increasing stack, right?
right.
And then
Yeah,
we,
let's
and then what do we put for n here for 11?
for 11 it's gonna be 1,
Okay,
right?
one. We say it's the length of the stack, right? That's what you
Yeah.
said. Okay, okay. We look at five. What do we want to store five? The result should be one, right?
um
Or yeah, like here, for
yeah we basically we want a monotonically increasing stack. So if I have 5, in that case I see that 5 is smaller than 9 and 11. So in that case I think I should ideally speaking pop like all elements from my stack, right? Until I find someone who's like smaller than 5, but then there's no one who's smaller than 5.
well, who can five see here?
5 can only see 11 right now.
Okay,
Yeah.
five can see 11, but nine is in the stack. So now let's explore the other. So explore the other method. We just saw that keeping it doesn't work. So we put nine, then we go to 11. 11 instead of putting it, we put 11. Now it's a decreasing stack. It's a monotonically decreasing stack.
Yeah.
Right, this one. Then we go to
And then
5. Okay, who can 5 see?
5 can only see 11, so I'll
Okay,
add that
so
to
this is
the
this one,
stack.
right? But Do
Yeah.
we add, now we say it's monotonic decreasing, so we add 5 here, right? So now we go to 8. So
Uh,
it's a decreasing stack. So what do we do with 8?
we see that 8 is greater than the last element in my stack, which is 5. So in that case, I keep popping from my stack, right? And then I
Okay,
get 2.
but what do we store in the result
Uh,
first?
like the number of times we were popping from the stack.
Okay, let's just say we returning the length of the stack because we see 8 and we can see 5 and 11, right? Okay, that's 2.
Yeah, 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 yeah.
Okay, now
So
we
then
see
we,
8, and now you said we pop it because we want it to be monotonically decreasing, so we get 8 here.
yeah, wait, I'm just thinking. So like we were at 11 and 5, and the only, um, like 8 is greater than 5. Okay, okay. I guess that makes sense. Yeah, yeah,
Yeah,
yeah.
like we
Cool.
pop 8 or 5 because it's smaller than 8, and now we don't pop 11, so now we have 11, right? Okay.
Yeah,
Pretend
and
we get
then
to 6. What do we do now with 6?
with 6, we just add that to our stack because it's in a decreasing fashion. Like, 6 is basically
Okay, but how
smaller
what do
than
we
the last.
update the res? What do we update the res?
Like 6 can only see 8, right?
It could see 8 and 11, right? It could see 8 and 11's taller.
Right, right, right. But then it can see both. But then the thing is that in my resultant array, like 6 can only see 8, right?
Which resulting array? This one?
Like what you've written in Xcali draw, like the drawing tool, like six can only see 8, right? Because it can't see 11. Like right here, 6 can only see one person.
Let's see. Oh yeah, you're right. Let's see. 6 and let me see. Wait, let's see. Yeah, six can only see 8 because they're covered. Is that the case? Let's see. Yeah, yeah. Six can only see 8. So we need to
Right.
update the stack differently.
Yeah, exactly. So I'll have to, in that case, pop both elements from the stack, right?
Which ones? All of them if they're smaller.
Yeah.
Okay, let's work backwards again. See, but the I think the main point is because we got a little confused here, but we need to actually try to simulate it because writing you went into writing the code kind of thing, and I don't think we'll be able to get to a solution if we unless we try to work it out like this, right? I think this for me. I think this is a good way to approach it, or will help us get there. Or is the way that I would do it in an interview.
Right.
But like, let's step back. Let's say we have a stack, right? And then we have an array, and we have a result. Okay, now similar way that I did it, or like, could you try to simulate it, kind of thing? Now, or
Yeah.
like,
So
yeah, try to follow that kind of step.
yeah. So like basically like I'm at basically like let's just say, I'm just thinking. So if I have a monotonic stack, I'll firstly have to store, like if I have an empty stack, so in that case, I'll basically add the current person's height to my stack, right?
Sure.
So so like let's just say I add like 9 to my stack. So stack basically contains 9, and then after that, I I think we should also use like a separate counter variable to count the number of visible people, right? So let's
Mm-hmm.
just say that count is 0 as of now. Um, count is 0 as of now, and my stack contains 9. So moving forward, I basically come towards 11, and I see that 11 is greater than the last element present in my stack, which
Mm-hmm.
is 9. So in that case, I increment my counter by 1, right? And then like I increment my counter by 1, and I pop the last element from my stack. So count has basically now become 1, and stack my current stack is again empty. So on the next iteration, I'm at 5. Since the stack is empty, I add 5 to my stack, and after that, I'm basically at my next iteration, and I see 8 is there, and I see that 8 is basically greater than the last element in my stack. So I'll just increment my counter from 1 to be 2 now. And basically, I'll have to pop like 5 from my stack now. And wait, I was at 8, right?
Um, yeah, I'm getting confused because you're saying a bunch of stuff, or you're kind of saying it out loud, and I think just try to manage the pointers here. I think it'll be better, and actually and manage the stack. Let's take a step back and slow down.
Okay, okay, cool.
So okay,
So,
start with 9. What happens? You push 9 onto the stack. Okay, and
and
then you move the pointer back. We're looking at 11.
yeah,
What happens
now
now?
now 11 is greater than 9, so I increment my counter by 1. Count is
You have a
initialized to
count.
be 0. Yeah,
Okay, count to 0. You put count equals to 1.
yeah. And once so like and I'll pop this element from my stack. So I pop 9 from my stack if the new index array of I is greater than like the last element present in my stack.
Okay, you put 11. Okay, so it's a it's
Uh
a
yeah, and then I put
increasing
11.
stack then. Or yeah.
Yeah, yeah, yeah.
Okay.
And then I'm basically now at like 5, right?
Yeah. Okay. Now what do you
Now
do
I'm
when you fire?
and then 5 is not greater than 11. So in that case, 5 is not greater than 11. So I
Or what's
basically
the result here? What did I store here for 11?
for 11 you basically stored the count, right?
Okay, 1. Okay, now we're here. Okay, continue.
Yeah. So you're basically at 11, right? And then like you have no, sorry, you're at 5, and you see that 5 is not greater than 11. So you basically don't pop anything. But in that case, like if you still have an element present in your stack, you increment the counter by 1.
Sure.
But um like if I increment the counter by 1, like we know that if the stack is not empty, then the current person can basically see the next taller person, right?
The stack is not empty. Oh, I don't know what you mean by that. Could you explain it?
Yeah, sure. So like let's just like go a step back, right? Back to 9, like just so that I can explain this better. So my stack is empty. So like in that case, I add 9 to my stack, and visible count is basically going to be 0, because I'll just like res of I basically becomes my count, my current count, and then I basically move like a step back, and now I'm at 11. Uh, Now I'm at 11. 11 is greater than 9, so I increment my counter. So my count now becomes 1, and I pop the element 9 from my stack. So now my stack is empty, right?
Mm-hmm.
Uh, so I'll now so now I'll basically add the current person to my stack, which is going to be 11, and I'm basically going to store my current count in my resultant array, so that becomes 1. Next, I move like a step back. I'm now at 5, and
Yep.
at 5 I see that 5 is not greater than 11. So, but I see that there's an element in my stack, so I increment my count by 1, um, and I append the next person in my stack. So that becomes, I think, 5 comma 11, right?
Or why'd you push it to the front? Is it a
Yeah,
stack?
sorry, push back, my bad. Yeah, that becomes 5, and then basically I store count as 2 in my result. But then what I'm getting confused is that we saw that 5 can only see 11, right? The next person who's taller than him, not
Mm-hmm.
9.
Mm-hmm.
So there's something wrong with my algo so far. Like that's what I'm thinking. Like
Okay. Let's debug. So,
yeah,
well, you're at 5. You push 5, and you put 2. What is person 0 1 2?
like I think something is going
Okay,
wrong.
this
Like
E4.
I shouldn't have appended 11 to my stack. Maybe that's what's wrong.
Okay, pretend we push. We're looking at 8, right?
Yeah.
So if we're looking at 8, what can 8 see? It could see 5. It could see 11.
Yeah,
But
so like if I'm at 8, 8 is greater than the last element in my stack, which is 5. So in that case, I'll have to increment my counter by 1, right? And then pop that element from my stack. Do you want me to code
Wait,
it out?
okay. Um, code what up? I don't think we have a solution though. That's the thing. Like,
I think I have something in mind.
would you be able to just explain it on the note or no? Because if you have it
Uh,
in mind, or are you more like, I'll code it up and then I could figure it out as we code it kind of thing.
yeah, like I think I'm more like that type of a guy.
Because let's see, we're looking at 8, right? I mean, you
Yeah.
can go ahead and try to code it. We have like 10 minutes left. Try coding it then. But usually, what I like to do is just make sure that they know what they're gonna code before.
Oh, okay. Yeah.
Cause,
So
cause like, yeah. Once we write the code and pretend they went in the wrong direction or they like, I see like how it might help.
yeah.
So just go ahead and try to write it. Let's see.
Yeah, sure. So, I have a local counter like initialized to be here, and then I'm basically gonna start like at like len of array -1, basically at the last element, and then like while I have an element in my stack, and basically array of I is greater than the last element present in my stack. In that case, I'll increment my counter by 1, which is
Mm-hmm.
what I was saying, and then pop that element from my stack, right? And then like I know that if my stack isn't empty, in that case, the current person can basically see the next taller person. So in that case, like if I have if stack, so in that case, I can basically increment my counter by 1, because you can see the current person can see the next taller person, right? And then I always add the current person to my stack. So stack dot append that is array of I.
Mm-hmm.
And then basically what I'm thinking is that I'll store the counter in my resultant variable, right? So res of I basically becomes my count. And then maybe what we can do is like try printing out res here, right? Can I like
Run
run
it.
this?
Sure, run it. Let's see.
Yeah, I'm not sure. Like,
This assignment's out of range.
so like I should probably initialize this to be an empty stack.
Well, you already had stack up here. Isn't it?
Oh, sorry about that. So like the solution for that was 3 1 2 1 1 0. It's like we're doing something, we're I think we're almost there, but then why aren't we getting 3? That's like something I'm trying to debug. Because like where's the drawing tool? Yeah, so because like 10 can see 6, it can see 8, and it can see 11. So let me like um res of I is equal to count.
Okay, just fix this part.
Yeah. Yeah, I think that is why it was wrong. Yeah.
Nice. Okay, let's try running this.
Yeah. Let's now run through this.
Okay, can you
So
dry run it for me on the code?
yeah, sure. So count is basically 0, right? Um, stack is currently empty, so I start at the last index. There's no element in my stack currently, so in that case, I just append like array of I, which is basically going to be 9. So in my stack, I'll append 9, and then res of I is basically count, and we know that count currently is 0, so this becomes 0. Next, I move forward. I'm now at 11. 11, basically I have like an element in my stack, 9, and 11 is basically greater than 9, so I increment my but yeah, sorry, I have to reset my count every but okay, it's all right, it's already at 0. So I increment my count by 1, right? And then I pop the element from my stack, so like there's no element in my stack.
Mm-hmm.
And I append the array of I, which is basically going to be 11, so I have 11 now in my stack.
Nice.
And res of I becomes count, so that
Mm-hmm.
is just one right here.
Yeah.
Moving forward towards the next iteration,
Yeah.
I'm basically going to be at 5,
Mm-hmm.
and I see that 5 is not greater than 11. but I do have an element in my stack. Also, obviously, I'll have to reset my count to be zero, right? Because it's inside the for loop.
Mm.
So now this becomes one because I already have 11 in my stack,
Yeah.
and I basically end up appending like five to my stack, right?
Mm.
And I basically push my count to my I basically push the count to my resultant array.
Sure.
I move back. I'm at 8. I see that 8 is greater than 5. So I increment my count to be 1. Like obviously it was reinitialized to 0. So count becomes 1 now.
Mm.
I pop the last element from my stack. So end up popping 5. I see that there's like one element present in my stack, which is 11. So I have a next dollar person. So I end up incrementing my count by 1, and I append 8 to my stack, and I basically push the count to my result. So this ends up becoming 2, and then basically now from 8, I'm at element 6. I see that obviously I'll have to reinitialize my count to 0. At
Mm.
6, I see that 6 is basically not greater than 8. So but I do have elements in my stack, so I basically incrementing my count by my I increment my count by 2 here, because like I have two elements in my stack, and I basically end up appending 6 to my stack. And in my result, sorry, my bad. Like it's not while stack, it's if stack. So in that case, I'll just like increment it by 1, not 2. That was wrong. And basically, reservoir basically becomes count. So this becomes 1. I move back to 10, which is my last element. Um, at at 10,
Yeah.
I see that 10 is greater than 6. 10 is greater than 6, and I have elements present in my stack. So I basically, like 10 is greater than 6. So, and 10 is greater than 8. So I increment my count by like 2, count by 2, because like I have 6 and 8 with 10 who's greater than 6 and 8. So I end up popping both of them. And like I have another element present in my stack which shows
Yeah.
that I have another greater height. So I
Mm.
increment my count another time by 1. That becomes 3. And I end up appending like 10 to my stack here. And res of I basically becomes count, which is 3.
Yeah.
And I'm basically done with my for loop.
Yeah. Nice. Okay. Yeah. Makes sense now. Right.
Yeah, yeah,
Okay.
yeah.
Yeah. We're pretty much at time now. So what do you think? How was that for you?
Like I think it was like I had done like a monotonic stack problem before, like, but it had been like too long, so it took me quite a bit of a while to figure out like how to come up with the solution. And I think like I had a solution in mind. I was unable to like comprehend that like sorry, portray that properly to you. But like as soon as I like, usually what I do is like I end up coding it, and like side by side I end up like dry running it and seeing that if
Mm.
the logic I'm seeing tries to make sense. So I think it worked out at the end. What would you say? How would you rate me? Like,
Yeah. I would say, yeah. You mentioned the monostatic stack in the first 2 minutes, but then it was about like 45 minutes until like it took about 45 minutes to implement it. And the reason I was pushing you to show me the solution in the comments is because most interviewers will not prefer you to just start writing code and then figuring out as you go. They would
right,
want to first off they would want you to read the solution, ask some clarifying questions, then they'll want you to start proposing your solution. Oh, I want to this is a brute forest. It might be slow, so maybe I'm gonna do a monotonic stack, and that's gonna lead to a faster solution, right? Like talking up front of how you're going to do your algorithm, and then once you figure out the algorithm and we figure out the approach, then you go in and actually implement it. And a lot of the times, I'm trying to see that if you're actually implementing the code based on the proposed solution that you said. So it's a
right,
negative signal if somebody's, oh, I'm going to do this, and then they start writing the code and it's completely something different. Like, think about it in the aspect of where we're working on a project and we need to think about things up front. At some point, you might be able to iterate it and be able to get to it, but if we can't plan the algorithm and solution up front, then we can't plan a lot of the project. We can't plan a lot of things because we need to be able to I'm basically just seeing your communication and planning skills, right? It's like this is the algorithm we're gonna do. It's gonna be event time. This is I'm gonna do a increasing monotonic stack. and then you go ahead and implement that, and the algorithm that you created should match what you proposed, right?
Right.
So I would practice like thinking of the problems up front and the solutions up front, and being able to communicate that with the interviewer up front before you start coding. And then there are going to be little things that we need to figure out when you start coding, but it shouldn't be big parts of the problem.
Right.
Does that make sense? That kind of feedback?
Yeah. So like effectively in any like in most interviews, it's like more effective for me to like begin by like walking through my thought process and like obviously explaining the brute force solution. I think I forgot doing that. Like it instantly clicked that this was something similar to a monotonic stack question. I think there are like a few extra points associated for the same, right? Like if you explain the brute force like just verbally.
Yeah, you don't even need to. Not every time you need to explain the brute force, but usually, if you look at the criteria for a lot of companies, like did they clarify questions? Did they ask clarifying questions? Did they propose one or more working solutions? Did they produce the optimum solution? When they wrote the code, did their code reflect what the solution that they proposed, or did they have to fix a lot of things on the fly?
Right.
Right? Is there are they able to talk about runtime complexities, etc.? Like, have they do good communication? Because as an interviewer, it's it goes all over the place when you're like, okay, you're just writing a bunch of code and then working through the solution at the same time. Like, I don't know, maybe I just it's I've been on here for 10 hours, so, but I don't know. Chat, was it kind of confused? What do you sort of prefer? But all I'll say is, like, from when I had to do interviews and when I had to assess people, that's a lot of my criteria is: did they clarify the question? Did you propose one or more working solutions up front, and then not start just writing code? Like, it's a negative signal if they just start writing code right away without ironing the solution. In your case, it worked out, but I've seen candidates who they just start writing code and they went the completely wrong solution, and we could have ironed it out right away if we just talked about it up front, right? In this case, it worked out for you because you kind of figured it out, which is good. But yeah, I think the main thing I'm trying to get at is you just need to follow a more structured approach when it comes to your, like, the way you come up with that, or the way that you, like, conduct the interview or do the interview.
Got it. Thank you so much,
Yeah,
James.
that makes sense. Like pretend. I don't know if you're watching the system design one, but my advice to them was to just have a more structured approach of just following things in a certain order. Because pretend they're like, oh, they start building out the how the server connects to the server connects to or sorry, the front end connects to the server to the database. Then they go to the functional requirements. Then they talk about the database index. Then they go to the API, and then they go to back to the non-functional requirements. Right? It gets confusing. It's like it's not structuring the ideas properly. So I think, yeah, just following a more structured approach, and yeah, just have things more ironed out before you start coding. I think coding should be the last step, and coding should happen pretty fast, and you should, like, not have to iterate on the code that much because you already have a clear idea of how you're gonna solve it. But honestly, you solved the question. It's a hard leak code problem. You did good. Um,
Oh wait, it's hard.
yeah,
Oh shit! I thought this was more like a medium. Oh
it
my.
depends. Some people, if you look at the discussion, people say that it should be medium, but
Uh.
it's tagged hard, so it's still a hard problem. But
Oh my.
I had to give you a hard. But the acceptance rate is decently high on it and stuff. So I would say it's a medium-ish hard, or just a medium. Or Paul said it's 2,100 elo, so I guess it's pretty hard, which is super high for
Cra-
that problem. Um,
Crazy.
but yeah, honestly, you were able to solve it. Good job. My main thing would be um, figure out a better, or follow a better approach to solving the problem. I think honestly, it was the perfect question for you, because if I asked you anything easier, you would have just solved it. But this one, it
Right.
really tested you and made like we uncovered some things that could help you improve. So I think that's good.
Yeah, I agree. Like I've not like I've solved like a lot of questions. So there was like a high probability I'd seen the question before and like know like at least like how the algo works at hand. So like thank you so much. Like this is definitely a question which like pushed me in terms of thinking. You know like
Yeah.
how to like refine my code, and then implement my solution. So thank you for that,
Yeah.
James.
Thanks for coming on. We should do this again sometime. I actually really enjoyed that session. Just hit me up whenever. Look, I'll send you another link to sign up. But good luck on your studies. You're only second year, so like chat. This guy's only second year. That's pretty insane. Um, you have a lot of good ideas. It's just like the structuring part of it. As I mentioned, like just making sure your thought process is structured. Otherwise, you could have easily blew that um, algorithm out the water and just had like a very strong hire. I
Yeah,
think you're very close to that if you had the right process.
got it. Yeah,
Cause
no, thank you so
you
much.
see how like how when we started using the stat or we started using the comments, it kind of like helped guide you a bit, or it started getting your mind there of like how we're gonna do it.
I
Like
agree. Yeah, was that? I think this was like a lot of help, though, right? Like compared to like a normal technical interview.
yeah, like I don't know if I would have like helped that much during a regular technical interview, but yeah, it's a harder question, so I gave more advice, and yeah, I don't know. This is just about practice, right? I just want to make sure you got something out of it as well.
Absolutely. Yeah. Thank you so much. No, I
Yeah,
agree. Yeah. Like if you wouldn't have like pinpointed me towards like using like both approaches, thinking if it's going to be increasing or decreasing, I might not have thought of it. Yeah. So thank you so much.
yeah, because I just remembering you. Yeah, you were there, and you're like, oh, should I do increasing, decreasing? Should I take the length of the stack? Should I like? You should think about that and sort of explore it a little bit, and not explore it in your head, because a thing you'll see with a lot of candidates is they'll explore solutions in their head, but I'm not in your head. And even if you just explain it to me out loud, like I might not be able to figure out what you're actually thinking. But when you put it into the UI like this and you show me how it's working in your head, it's more clear for me. So for
Got
example,
it.
like the you know what I mean? Like if you're like, oh, I have a stack, I want to do it. I want to talk increasing or decreasing, and you're simulating it in your head. But for me, as I'm just watching you think, I don't understand where you're going with it.
I agree. Like my thought process was cluttered like all over the place, and like yeah, I should have worked on that.
Mm-hmm.
Could I ask you like something about like the other data structures?
Sure.
So, like for example, if I have a DP question, am I supposed to like let's say go from recursive to like memoized solution? Do I have to tabulate that and like optimize it to like 1D, like using like a 1D array, or like how much optimal does it have to go?
I mean, it depends on the company you're interviewing for. I would say if you're working at if you're targeting hedge funds and stuff, they ask more DP, but FANG companies really only ask, um, only Google really asks dynamic programming, and most of the time for them, top down memoize is good enough. If you it depends. Some people can figure out the top down memoize better, easier than, but some people can think of bottom up easier. But
So sure.
usually, the main thing is what I like to do is I start to do top down, then memoize, and then if I can come up with a bottom up, I'll do that because when you come up with the bottom up, usually you could only do the very spaced optimized algorithms with the bottom up solutions.
I agree. I agree. Yeah, like I'm targeting hedge funds like down the line. I mean, I have like
Nice.
5 more co-ops to go, but so I guess it's like best like for me to, really go down to like 1D DP and like optimizing the space complexity as well.
Optimize space complexity. Figure out where do you should probably do code forces more than anything. Everybody that I know who worked at a quant that's coming in this channel, because we had people working quant hop on this channel and they do code forces, which is some more combinatorics and probabilities and some math, solving
Yeah,
questions that involve that.
I saw like the videos of like you with Moses like doing
Oh,
the.
you know him?
Yeah.
Nice,
I met him too. Yeah, he knows me.
nice.
Super smart guy, I
Yeah,
must say. ICPC and God knows what else. Like super
nice.
crack.
Yeah,
And yeah, I mean it's been fun. Like you had like Richard coming into, so I've been following you for quite a bit.
wow, you know all
It's
them.
been a
Nice,
journey.
cool. Yeah, good luck. You're only in second year, and I gave you a hard question. Honestly, it's just more just like having a structured approach. Richard did
Sure.
really good on his. I remember.
Yeah, yeah. Like he grinded the hell out of lead code. Like he's done like 600 questions or
Yeah,
so.
yeah.
I gotta get there.
How many questions have you done?
I've done like 180.
And honestly, what I would say is if you did 600 questions, it might not even make you any better because you're already good. I would focus on actually working on questions that challenge you. You could do 400, 500 more questions if you just did medium questions. I don't think that'll set you up well for a hedge fund. But since you're already good, I feel like you're actually pretty good already. You could probably do harder and harder. You should do more hard questions than mediums. Unless you could
Got
already really do a lot of medium. Or unless you still struggle with mediums, I'm not sure. But
No, no. I think I can do most mediums comfortably.
yeah, I would
Yeah.
just literally focus on hard questions then for you because you're already good.
Right. And like just another thing, like have you seen like DSU come up like as an optimization for like
The
most graph
disjoint
questions?
set,
Yeah.
like union find.
Yeah, yeah, yeah.
Um, yeah, I've seen it. I've never had to do it in an interview, but I mean it comes up often. I've not, actually never had to do it in an interview though. Like implement a DSU. It's kind of niche. If you think about it, DSU is 10, 15 lines, and then usually you can solve the problem in less than 30 lines if you use a DSU.
I agree. Yeah.
Doesn't really,
Highly.
yeah, it's kind of very specific. If I'm making hiring decision and the dude doesn't know what a DSU is it good to reject them just because they said they didn't know what a DSU is? Like, do you think that's would you just reject someone for not knowing what a DSU is?
No, no, hell
Exactly
no.
right. But if somebody couldn't work with a set, then I would be like, okay, that's kind of crucial.
I
But things
agree.
like DSU, heap. I would expect someone to know a heap, but like a dish like union find, I wouldn't not pass on someone who doesn't know what a DS or union find is in like 90% of the cases, unless my company really is using dish like union find. But
Yeah, like if it's Citadel, I guess might as well know everything, you know.
yeah, yeah, cool. Thanks for hopping on. We'll take a
Yeah,
little break.
for sure.
All right.
Thank you so much for your time,
Yeah,
James.
no
I
problem.
really
Thank you. Thank you.